So, hello everyone. Uh, Today, I'm going to presenting a hands-on demonstration of setting up Hadoop environment using Docker containers, and we'll explore how to simulate uh, basically big data storage and data processing in a containerized environment. So understanding should be why Hadoop and why Docker. So Hadoop, as we all know, is a powerful open source framework, and that allows the storage and processing of massive amounts of data across clusters of computers. And Docker is a tool that allows you to package and run applications in an isolated environments called containers. And this makes it easy to, create, test, and deploy applications in the real world scenarios and the business environment. So why we combine the two basically? So Docker, makes it incredibly easy to set up, manage, and scale Hadoop clusters without needing a physical container. So this means we can stimulate Hadoop and Hadoop environments for learning, testing, or development process. Also, all within Docker's containers on a single machine. So the first step is to understand that we are taking Excel tables, creating Excel tables. So as you can see here, there are four tables. We have products, customers, order, and order details. This would be our first step. So in simple terms, why we are creating tables? So we are creating tables to stimulate, data that we can store and process using Hadoop. And these tables represent the kind of data that might be stored in a big data environment. And by converting the Excel tables to CSV format, we can upload the data to HDFS, basically Hadoop distributed file systems, and which is the storage system of Hadoop. So this helps us demonstrate how Hadoop handles large data sets in a distributed way. So we are taking four tables basically in order to understand how it is interrogated with the Hadoop environment, and we'll also further will run the SQL queries as well. So why we are setting up Hadoop and Docker? So Hadoop is a big data framework that's, as we already mentioned, that stores and process a large amount of data across many computers or nodes, and setting it up in a Docker allows to stimulate this distributed system on a basically single machine without needing a physical cluster. So as we have created four tables, so after doing this creating these tables and converting it to CSV, we will proceed with our terminal window partial. So we'll first will do our Docker login. So as already mentioned over here, so as you can see that authenticating the existing credentials. So we see our login succeeded, as you can also have the Docker open desktop. And what else we'll proceed with that? So basically you have to install and set up Docker on computer if not already installed, and you have to run the setup in Windows PowerShell. Apart from that, we'll pull the necessary BD images to create a Hadoop environment for data storage and processing on Docker. So how we'll proceed with that? So as I've already created few codes, commands that are necessary in order to pull the images in our container. So first, we need to understand by creating, this framework, we'll understand that these large amount of data and helps us to pull the necessary BDE and images to create a Hadoop environment. So basically, the BDE refers to big data ecosystem. So is to collect of Docker images that provide the necessary infrastructure to run popular big data tools. including Hadoop. And these tools often involves HDFS for storage and MapReduce, or Yarn for processing data. So when setting up Hadoop and Docker, you need images that contain the services required to create the Hadoop cluster. So these images provide the foundational components of a Hadoop cluster, such as HDFS for storage, Yarn, yet which refers to Yarn, another resource negotiation for resource management, and MapReduce for data processing. So Hadoop basically in Docker is a convenient way to stimulate a distributed environment without requiring full-fledged physical center. So I'll just come over here and uh, need to pull few images with the code. So you can just simply copy it and paste it in a terminal. So as you can see, the status image is up to date. So I have also pulled the image earlier as well in order to understand the feature. So again, you run all the commands one by one. So as I have already pulled the data that is required, the BD images. Now the next part is to understand to create a node, name node, and multiple data node containers on Docker. So in order to start with that, we'll first create an isolated Docker network. So basically, why we are creating an isolated Docker network? So containers and Docker, need to communicate with each other. So the name node and a data node need to talk to each other to manage and store data. So by creating a single isolated network, we ensure that these containers can find each other and share information, just like real Hadoop nodes works. So I'll just, copy this and paste over here in order to create the. Yeah, so as you can see, the network with the name Hadoop network already exists, as I've already run over here. And you can see I have also created a name node, data node 1, data node 2, data node 3, as I have already created. But there should be a basic understanding of how we are running the name node. So you just copy this name node code over here and put it here. The name node is already created and it is running. So if you see that I have also created multiple data nodes as well. So if I'll just take the code of the data node and put over here our window terminal. And instead of putting data node 4, changes and put it over here. if I'll just change it to that particular node and copy it from here to over here. It's already running. So as the nodes are already running in my works environment. So as in it is the master node basically that keeps track of all the metadata in the Hadoop distributed file system, and it maintains information about which blocks of data are stored and of data nodes and control access to the file system. And here the data nodes, and these are the nodes that I've already run, and these are the worker nodes in a Hadoop cluster that store the actual data. And a Hadoop cluster typically has multiple data nodes to ensure, like data redundancy, fault tolerance, and scalability. So by creating a name node and multiple data node containers, we are stimulating the distributed nature of the Hadoop cluster. So as already mentioned, that name node acts as a master node, and why multiple data nodes? So in a real Hadoop cluster, data redundancy is achieved by replicating blocks across multiple data nodes. So these ensures fault tolerance. So if one data node fails, the data can still be assessed and accessed from another data node. And in this step, by having multiple data nodes, you are replicating this behavior in a Dockerized environment. So now it's time to add our data to HDFS, as I'm again logging into the Docker login, and also login succeeded over here. So I'll proceed with how to add data to HDFS. So we'll use this command specifically. So we are using this command in order to running the command basically inside the container. So by specifying bash, we are telling Docker to open a bash shell within the container. So we can also type it interactively. One second. Yeah, so it is successfully run over here. Now it's time to run this command in order to. um, so we can see that the file system and storage directory root, and if I just type, yeah. So now it's time to create a directory in HDFS. So this directory acts as a folder in HDFS where files can be stored. So we'll use this input and put it over here. Yeah, perfect. So, I'm sorry, buddy. Um, yeah. So earlier the command was not working. So I have, if you can see that I have created the data node 4 using this code. Um, Here is the code. So it's just simply that you'll change this code as data node, and you can put data node 1, data node 3, data node 4, data node 5, how the multiple data nodes as you want. and what is required for the organization, specifically if we think from the business perspective. So as we have already created and the multiple data nodes and name node, and we have already added data to HDFS as well. Now it's time to create a sample file inside the name node specifically. So in order to stimulate data, we have to create a simple text file um, within the data node. Yeah, within the name node. Uh, so you can also give the file that you are creating either a test file.txt or sample file.txt, and I'm taking here as a sample file.txt. So I'll put this command over here. So it is successfully run over here. Now it's time to that means that you have some data to be added to HDFS. And you have already some data to add it in HDFS. And the part of the sample .txt, which is specifying the path and the name of the file where the text will be saved. And it also specifies the file path and name, and is also a file path that points to the location where you want to create and save the file. And if you see the symbol redirects the output of the command into that particular file name. And this at the beginning of this file provides uh, provides information that the file is created in the root directory of the containers file system, but not in a directory. So now it's time to, upload the sample files to HDFS. So adding this sample .txt file to HDFS, which ultimately means to upload data from the local file system inside the NameNode containers to our HDFS. So we'll use this command and put it. So yeah, it is showing that the file already exists as I've already run above as well, somewhere here. Yeah, as you can see over here as well. So that's where the output is coming out as files exists. So now it's time, to verify the file in HDFS. So I'll run this command. So you can see that it is that we found one item. So that means it is very useful that we got the confirmation, and it helps it helps us to understand that the file that we have made, either it is sample.txt or test.txt or any file that we are creating, is indeed in HDFS, and it is present, and it is in the correct directory. It also helps to understand the troubleshooting, and if there is any issue, example ex- uh, example that the file didn't upload correctly, and the step allow you to catch the problem early and troubleshoot, and ultimately it avoid errors that will get in the later stage. And if we also skip the verification, we might proceed with other steps, assuming the file is there, only to encounter errors later on if it is missing. So now it's so now it's time to, deactivating a node. So we'll uh check what happens with the data after deactivating or loss of one node. So will it affect the data node of another data node or not? Ultimately, it will not, obviously, because the data nodes are interconnected with each other. And as I've already mentioned that we can access the data from another node as well. So we'll see using the codes that we will be putting in the PowerShell. So we first, will stop one of the data node containers, simulating a failure here. And as you can see, the output as the data node one. Now it's time to, verify data availability after node deactivation. So after node deactivation, Hadoop should still be available to retrieve the data from the remaining replicas. Let's check if the data is still accessible. So we'll again copy the code and we'll put her in our PowerShell. Yeah, as you can see that as of now, there is no such file or directory, but we can access the data using this command, and this command reads the content of the sample.text and stored in HDFS, and this file should be accessible even after one node is deactivated. Hopefully it works. Let me try finding with the mm, replicas over here. Let's just start the data node one and check it again. Yeah, and verify the reapplication factor came again or not. Yeah. So now it's time to verify our application factor. So as we can see over here, we have four live data nodes and one replicated block in HDFS, but it doesn't directly tell us if the block is replicated three times, and it only confirms that the replication is being used, not the replication factor. So to check that the exact replication factor and see which node hold the replicas or the duplicates, and we use the HDFS or FSK command in the NameNode container. So this command will ultimately run in a NameNode container, and this command will provide detailed information about each file and its blocks, and where they are stored across the data nodes basically. So we'll run this command into the location over here. So we can see in the default replication factor we have three, and this this line default replication factor recommends and suggests and confirms that the default setting for replication is three, and this means that each block by default should be replicated on three nodes. And here we see the average block replication 3.0, which shows that on an average, each block in this file is replicated three times. And this confirms that the single block, the file that we have is the sample.txt, has three replicas distributed across the data nodes. And then we have minimally replicated blocks uh, that provides the information which is 100%, indicates that the single block has reached the required replication factor, in this case is 3. And if your block were not fully replicated according to the replication factor, it would be listed under replicated block instead. So now it's time to adjust replication factor. So we'll take this code from here. and put it here. Yeah, and we can verify replication factor change as well, again using the same code that we have used earlier in order to start our initiation for verification. So earlier, the average block replication was 3.0. Now it's we have changed it to 2.0. So as per our instructions, so we have adjusted the application factor like from 3 to 4, but we have been doing from 3 to 2, and we have also verified the changes. Yeah, so as we are proceeding towards adding our CSV files into Docker containers, so why we are doing this, a simple way is that a Docker container, as I mentioned, is a separate, isolated environment, and which is much more like a standalone, computer virtual machine. So this isolation of is one of the Docker's key feature. Um, And it also means that a container does not have a direct access to files on your host machine unless you specifically provide that access. And and we also copying files to Docker environment. And this method is like transferring files from our one computer or the local computer system to another. And we also copy the file from your host machine into the containers file system so that it becomes a part of the isolated environment. Now, what are mountain directories? And this method is like setting up a shared folder between your computer and the container. It allows the container to access directly on the host without actually copying files. And this is especially useful for development and deployment as well, as any changes made on the host are immediately accessible and like accessed and accessible within the container. So we have to first list the root directory of your container. So this means that we'll run this command over here uh, in order to get list. Yeah. So it runs since we need, so this will help us, to check where folders are in your Docker container, basically your virtual computer. So as we are creating new directory inside a container, so since we need, two folder in Docker data and files, and we need to write commands to create that data and files. So I'll copy this command, which is specifically for the data. You can see that this file is already exists as a above. Also, I have, access the data and the files as well. I'm anticipating it would be the same, error. It's like file exist. You can see it over here, data and files. So we are good to go in this situation. Now it's time to, copy the data. The four tables that we have created, we need to, put those tables over here. So these are our tables in our local directory. Here, order details, orders, customers, and products. And we'll put the codes of from a local computer to successfully copying. Yeah, so it is mentioned that the successfully copied to the name node. So as I have done it for the product, I'll do it for another three data set I have. We can also check that we have the data present over here or not. Yeah, so we have our all the files. And if when executing this for the very first time, the output should be empty because we have not created any folders in HDFS yet. Let me see how it goes. I haven't executed the customer's orders and I need to execute the customer's data as well. I think it is not executed for this one. Yeah. Now again, I'll run this particular code and I get it all. Yeah, I get the order details, block, products. Sure. So when executing this for the very first time, show the part. So I'm sorry for the glitch. So as you have seen that I have already created in the last video that the data file and the files which has already been exist over here, and also I have you know uh, added my CSV files. What are those? Like product, customers, order details, and other files which we have created. I've already put and successfully copied in our name node. Then we executed this command docker execute it name node as data in order to check whether our files over there or not. So we can see that we have our all the files what we have created. And later I subcheck, I place this command in order to the subcategory that I have created, and I have put it over here. And now we'll jump to creating the Hive server where we'll run our SQL queries. So in order to create the Hive server, let me just close this and again open my window partial. So before doing that, we'll pull image of Hive first. I'll just, pop it out. Sorry, stop. Login. Yeah. So I'll just first pull the image of Hive through the command line and put it over here. Yeah, so I can see that image is up to date that we have to create. And now we have to run our Docker container. So I'm gonna copy this code and put it over here and run the command over here. So it is successfully run again. Now we'll check whether the Hive container is running or not. So we'll just use Docker PS. Yeah. So we can have this container ID and image, and it is successfully running. Now it's time to configure our Derby database. So you come over here and we can see that our Hive server is still running. So we'll go to files, we'll check for the opt, then Hive, then we'll dig deeper into conf, and then we'll do some changes over in Hive site.xml, and we'll put the command and we'll replace the content of Hive site XML with this configuration file, and we click it save. Perfect. So we can see that it is perfectly running for us. And um, now we have already replaced this file with the configuration file that we have. Now it's time to set up of Hive on Docker. So we'll just copy this command of the schema tool and put it over here. And we can see that once the schema is initialized, we can start the Hive meta service as well. So we'll copy this file from the opt in order to see that it is running in our Metastore. Yeah, so it is running. So then we'll, just use Control plus C to stop the process and execute our next command on the Hive shell to running the Hive shell in order to get the IP address. So let me just, now I'll copy this to open the Hive shell with the advanced settings we need for the IP name node. Uh, Yeah, so we get it like 172.18.0.5, and we'll copy this. Our IP address maybe the IP address may be different for the different environment. So I'll just and so as you can see that we are in our Hive environment, and that would be our last step in order to run the SQL queries over here. And as we all started with the Docker environment and added data to HDFS, and then we run the Hive setup, and now we will run our SQL queries in the next video. So as I have already entered in Hive shell, and I tried putting few SQL queries over here, but it is showing me some error that table not found. So that means that there would be some issue with the location. So that will again go to the HDFS and will change the file locations and do some prominent changes over there. And then, so basically these are the SQL queries that we need to type in so I did like 15 operations over here, like to get all the customers' data. So this is something that we'll put in Hive and get the customers who have placed orders using the join operation, and also the count function, the as function, as what we do in MySQL and PostgreSQL. And we also do some mathematical operations like average, and you also categorize the data as per the specific product you want from the database. So these are the operations that will do it in Hive shell in order to get the information. So the insights that we'll get is to uh, s- understand the customer base, the size, and identify the most common names, which can be useful for our target marketing, and measure customer engagement, activity levels, and we'll also understand the quality of contact data, and we'll also identify the outliers and the gaps that will handle in future, and we'll also determine and investigate the most common email domains which customers use usually, and we'll also track customer registration over time. We'll also play with the real-time data as well in that case, and the latest data that we'll put into HDFS, and we'll also identify a potential duplicate record for data cleaning, and we'll also do some data quality issues in order to have the proper data cleaning for further data analysis. So that's all as of now. I'll make sure that I'll run these queries, but this is the overall concept. So thank you for watching.